Welcome. In this segment, we will talk about image projections. Let's get right to it. In this example script, I will show you what a image projection will look like inside Google Earth Engine, as well as how the image can be reprojected into other perspectives. Before I start, I just want to quickly mention the concept of image projection. Image projection is very similar to any other concepts of looking at something from different perspectives. If you are looking at a map, for example, from a coordinate system that is different from the one that is showing on the map, you will be looking at a map that's going to be completely different. So here we'll show you what the projection can look like and changed for different raster images. So as we always do in the beginning, we import the image. So I show that on line 7. That is where we import the Landsat 5 image. And then on line 10 is where we actually show the image projection that it's associated with this Landsat 5 image. And we do that by using the projection function, as I highlighted there on line 10. And then we print that in the console. And once we run that, we'll show you what the result looks like. We can also be able to get the pixel size inside that particular image through using this function attached to projection that's called nominal scale. That's where I'm highlighting there on line 13. And that shows you the pixel size in meters for this particular Landsat image. And if we run this result by hitting the run, when we go to the console here, you'll be able to see there are different results that were printed, as you can see on the screen there. The first one is the projection. If we highlight this, it will tell us what the exact projection of that image looks like. And here we have the EPSG 32618. You can definitely look up what this means in simply by Googling what this is, and it should tell you what the exact projection of that image is. And then the next result we're seeing on there is the pixel size in meters. That is 30, so that confirms us the Landsat image is presented to us at a 30-meter pixel size. And then we can also look at the projection of other images. Here we are going to go back to the script and starting on line 17. This is the second example. I'm showing you how we can reproject an image starting on line 18. First, we import an image. Here we import image from the MODIS satellite. And this image was imported on line 18. On line 21 is where we can show the projection of this image. And then we display this image in the map down below. And I will show you in a second how that looks like. We center on the image on line 25. So we don't need to go around the map to look for the image ourselves. And we also display the image on line 26. That is how we set up the image to be displayed. And then going on to line 29, As you see there, that's how we can assign another projection system to this image. And now, theoretically, we will be looking at the image from a different angle, which will see some kind of transformation to this image itself. So when I hit run here, first result I want to point out is this last projection that is showing in the console there. When I click this drop-down menu, you'll be able to see in the CRS, this is the projection of this modus image that I just imported here. And it looks very different from the projection that I showed you earlier. If I open up the earlier Landsat projection, that is the EPSG 32618. So that confirms to us the modus image and the Landsat image are stored in different projections. And if we want to reproject, we did that in our script. And let's see how that result comes out to be. So I'm going to open up the map. So there are two layers here, as you can see, the reprojected image and the original image. If I turn off the reprojected image, here you can see very clearly this is what the original modus image looks like. If I zoom out a little bit, you'll be able to see the entire image itself. And when we reproject this image to another perspective or projection, in this case, the image becomes completely looks completely different. So if I want to see some result, I have to zoom all the way out. Then you will be able to see there are blue squares up there that's showing you there's some data there. So this is the way that you can reproject an image for different purposes to fit your need. So moving on to the next segment here, we have, let me just comment this out real quick so we can focus on the script. Okay. So the next part of this is the image registration. It's very similar to the concept of image projection, but the image registration many times is you have to use it to match two images on top of each other. And many times when we are taking aerial photos at the same location, it's very hard to make sure you are taking it exactly at the very same spot. And image registration is a way you can use to mitigate that problem by matching different pixels of those images to find exactly match of those two images. And it has been used a lot for multi-temporal comparisons of things using images. So let's get right to that part. Let me just uncomment this so you can see it clearly. And we start by looking at line 38. And on line 38, as you can see there, that's where we import the first image, and then the second image we import on line 39. This is no new things, as we showed in previous videos. And the new things comes out to on line 42. That is where we start the image registration process by sample the image itself. And in this registration process, we first have to identify these distinct pixels that we can match them to make sure the image line up perfectly. And here, the resample function is used to resample pixels inside this bicubic uh, data layer inside the image. And then on line 43 is we apply the same thing for image 2. On line 46 is where we actually start to select the layer inside the image. And inside this select function, we used this R, which signals the near infrared band. So now we are just sampling inside the near infrared band to give us those pixels that we want to reference each other to. So as we showed before in Google Earth Engine, there are many different approaches to different things. So similar to the other approaches here we showed before, the image registration, first I will show you the first approach. In this first approach, we want to know exactly what is the offset of those pixels. So how is one image moved in relation to the other. And on line 52, we start by using the displacement function. And this matches the first image, which is the image 2 red band, as I'm highlighting here. Match that image with our reference image, which is the image 1 red band. So once we match these two images, we use the displacement function on line 52. We will be able to see what the displacement of these two images looks, and we'll show that in the console. And we also use the displace function on line 59. That is what the displacement is actually being used to displace our two images and to match them. So quickly, I want to just quickly show you what the displacement looks like. So if we just simply use the print function and we print the displacement of that, and we quickly run that, in the console now we are seeing this result, which is the image. And inside this image, it simply has only 3 different bands in there. So the 0, 1, 2, and then the x and y. So you see in the dx, dy, for the band 0 and 1, those contains how much the first image is moved in the x and y directions in comparing to the second image. So this is an image that contains the movement of the second image in reference to the first image. And if we go back to the script, on line 61, as I mentioned, we use that displacement to readjust the first image to line up with the second image. Then we displace the result. And when we display the result, obviously we need to establish some kind of visualization parameters, as I show on line 64. Then we center to our image so we can display better on 65. And then we display the two images, 66 and 67. So since I have already run this, let's just pull up the map and see how that looks like. So since this is an image from the SkySat, it is a very small but very high spatial resolution image, as you are seeing there. And the first image, as you are seeing, is the reference image. So it looks pretty much like that. And the second image I am showing you here is the second image we want to line up with the first image. And the problem with these two right now is they don't exactly line up very nicely. So if I zoom in, you will see that some of these rivers don't really line up. And especially if I go up here somewhere, into the road area, these problems will be more dramatic, as you can see there. So there's a divide. As you can see, it doesn't really match up to that. So if I run this script and we display the image after we adjust for the registration, we should be able to see 3 different images. And now you are seeing the 3 different images. The first is the reference image, as I showed before. And then the image that we are trying to reference and match up to this reference image down below. And then we create a image that is registered to that reference image. So let's zoom in a little bit, and we can be able to see there are slight movements of how this image registration corrects itself. So if I just do a quickly just move display the second image on and off, you can see the image actually moved a little bit to make sure everything lines up perfectly. And if we go to another area up here, like so, and if I quickly show on and off, you'll be able to see very clearly there are area of the image of the second one that has been moved to match well with the reference image. So the second approach, as I show on there, so I'm going to close the map, and then we'll focus on the script. As I show starting on line 70, that is the second approach you can do this exact same image registration. In this example, if I comment it out here, you'll see a much simpler and much clearer way of doing the registration. And this, comparing to the first approach, we are not actually calculating the displacement of the second image in reference to the first. We are only using this register function on line 73, where I'm highlighting there. That is just one function you need to use to match the first image to the second. And in this case, we will have no way of knowing how much the image was off of the first one compared to the second one. But the exact same thing will be displayed. So on line 78, that's where we display the registration result of the second approach. And technically, we should be seeing exactly the same. So if I run this real quick on the top, I hit run, and I open up the map. Now we are seeing 4 different images there. And when we zoom in, I'm just going to show you layer by layer by turning the image on and off real quick. So the first layer you're seeing is the reference image. As you see, we've seen this before. And then the second image is this raw image that doesn't line up very well with the other image. And then this image was corrected by the first approach. So now you're seeing this image is the result of the first image registration approach. And then this is the second image registration approach that we did. So the first and second one should line up perfectly. If we zoom into an area down below here and just focus our on ID river, we should be able to see there is a perfect alignment of the river. And as I turn off the first result for the first approach, you're seeing the result from the first image registration approach. And then as I turn on the second one, you're seeing another approach. So the first and second approach doesn't look exactly the same. So if I just toggle it on and off a little bit, now you're seeing a different image that has been moved a little bit. According to your own use in the image registration, choose the appropriate one as for your own need. But personally, I would recommend the first approach since it tells you how much the image is off by x, y directions in reference to the first. So there you have it. This is how you can process image projections and also look at the image registration approaches. In the next segment, we'll talk about the image shadows and how we can process those. Thank you.